Okay, hopefully you've seen that steam engine. So a coal-fired or an oil-fired power station works in the same way as that steam engine or the steam power station. So what happens is we put fuel in and we burn the fuel and release heat energy, which then heats that water and turns it into steam. The steam moves along here and it turns a turbine which spins round. Okay. Then that turbine is connected to a generator which also spins. And then that generator produces electricity. So the energy changes, and these are really important, involved in this are. So if with fuel, the chemical energy in the fuel turns into heat energy. And then that heat energy moves the turbine. So the heat energy moves and changes into kinetic energy because it moves the turbine. In the generator, it produces electricity. So that movement, that kinetic energy, produces electrical energy. And in the lamp, we all know what the energy change in a light bulb or a lamp is. It's electrical to light and heat energy. Okay. So how does that generator work? It's not just magic. It doesn't just turn into electrical energy. There's something behind it. And we're going to look at that just now. So I will show you a video of this experiment, but I'll just talk you through it first of all. So this experiment, there are three sort of mini parts to it. And then so the first part, we're using a wire, just a long wire, insulated wire. So that means it's covered in plastic. A pair of magnets, which are here, that's a magnet, and that's a magnet. And also an ammeter. So that just tells us if electricity is present, even electricity is present. Okay. So the first thing that we do is we just get this wire, we connect it to both ends of the ammeter, and we just move it up and down between the magnets. And what do we notice? Well, nothing happens. I mean, you probably expect that if you just move a piece of wire between some magnets, not much happens at all. Nothing. Now, if you wind that wire around, it produces a coil. So maybe a few times around your fingers, and then you move that coil up and down between the magnets, you actually do get a little bit of electricity. It's only a tiny little bit, but you do get a little bit of electricity on that ammeter. So small amount of electricity produced. So, okay, so if we move a coil of wire between some magnets, we can produce a little bit of electricity. Then the third part of this experiment is using what we call a 60-60 turn coil. So that's like 120 coils of wire. Okay, so it's more than we can do around our fingers. And it usually looks a bit like this sort of rectangle here. So what's inside this rectangle? Lots and lots and lots and lots of coils of wire. And we've got a bar magnet as well, which is this thing here. And we've still got it plugged in to show an ammeter that shows us if we've got some electricity happening, okay, or being produced. So in this case, what we were doing is moving the coil next to a magnet. In this case, what we do is we move the magnet in and out of the coil very quickly. And what we see is quite a large reading on the meter. So a larger reading on the meter, showing that, the more coils there are, the more electricity is created. So moving a magnet next to a coil, or in and out of a coil, or a coil over and over a magnet, can produce electricity. Okay, obviously, if we're just doing it by hand, it won't produce a lot of electricity. But if you have a machine doing this, or if you have a turbine spinning it very, very quickly, then you can produce a lot of electricity. So in summary, when a magnet is moved beside a coil of wire, or a coil of wire is moved beside a magnet, electrical energy is generated. There are three ways to increase the amount of electrical energy that's produced. You can move the magnet or the coil faster. Let's try that again. You can use a greater number of turns of wire, so that means more coils, or you can use a stronger magnet. And stronger rather than bigger. You can have a huge magnet, but it could still be quite weak. Okay, so you could have this big one that you're carrying around, but it might not be very good. A stronger magnet, usually the strongest magnets are the smallest ones, so a stronger magnet. And a bicycle dynamo uses the same principle. When you turn the wheel, a magnet is spun next to a coil of wire. This generates electrical energy. So if a magnet is spun next to a coil of wire, or a coil of wire is spun next to a magnet, it can produce electricity. So you can see here, that's a coil and it's being spun around this magnet, okay, and it produces some electricity. So it can light, it can give you some bike lights while you're moving your bike around. So it's actually quite handy. Okay. And the generators in power stations are large-scale dynamos. So hopefully I'll be able to get you a video of this as well, the model hydroelectric power station. So a hydroelectric power station uses the same kind of physics in terms of it's doing some spinning of magnets or coils to produce electricity. But instead of fuel, we use some water. Okay, so what a hydroelectric power station consists of is we've got basically some water up a hill, and it flows downwards. And at the bottom, we have a turbine which spins round and it's connected to a generator which can then go on and produce electricity in a light bulb. So the water comes from a reservoir high up in the hills. When it sits high up in the hills, when it's up high, we know that it's got a special kind of energy, gravitational potential. As the water runs down the hills, it loses that gravitational potential energy, but it gains kinetic energy. The running water makes the turbine spin or turn, and the generator converts the kinetic energy into electrical energy. Let's try and write that one again because that did not go well. I'm sure you can write it yourself. So electrical energy. And that's a picture of the Hoover Dam in Colorado. So basically what happens is a lot of water uphill, and if you need to produce electricity, you release the water to go down the hill, which will turn a turbine, which will then be connected to a generator, which will turn the kinetic energy into electrical energy. Okay. I'm going to stop there.